the traditional relational database model. In days past, a relational database model was built based on primary keys that reflected the information in the tables. How do we demonstrate that? It's a little bit difficult with this particular model. So what I'm going to do is I'm simply going to delete it for now. And I'm going to go back to my old faithful customer database model. So once again, we'll have a customer table, and it doesn't necessarily have to be the same, but we have a customer name, and we have a customer address, and let's say we have the balance he owes us, balance owed, etc., etc. And then we have an invoice table with an invoice number and an invoice amount and an invoice date. And we also have invoice item, and that table has item date and item amount. So now let's go and put our links in here. What I have here is a customer. The primary key is the name of the customer. It's a long character field with the name of the customer, such as Microsoft Software or Oracle Corporation, etc., etc. Could even be a name that's 50, 60, 500 characters long. The invoice has the invoice number, which could be an alphanumeric key. It could reference all sorts of things. It could be 50 characters long. In fact, one thing we want to add to this table is an invoice item number. What we need to do here as well is to change the sequence of this. And we need to change the sequence of this as well. What do we have here? The customer has a unique name or a unique primary key identifier referenced by the name of the customer, a great big long character field. When you have a customer table with millions of rows in it and you index based on a customer name, which could be many, many characters long, you have a large index. If, for instance, the customer address is blank, he has no balance owed, the table could theoretically be more or less exactly the same size as the index. That's a problem, because when you read the table and the index, you're not necessarily saving any time. That's the traditional factor of this structure, using the customer name. Also here, what's happened is the primary key from the customer has become part of the composite primary key of the invoice, which is actually correct, the foreign key plus the invoice number. Obviously, with an invoicing system, invoice numbers are unique because of income tax restrictions. However, for the traditional model, you need to reference the invoice by the customer name and the invoice because there's no other way of finding it. It gets even worse as you go further down the hierarchy into the invoice item table, where you've actually got a 3-column composite primary key. That's just nasty. It's inefficient. The customer name could be many characters. The invoice number could be many characters. The only thing that's potentially short is the invoice item number, because it's the lines on an invoice. Typically, a company issues an invoice with, say, 10, 20, 50 lines on, not 5 million. So that's not necessarily going to create inefficiencies. The only issue here is that we have more columns in the primary key than are not in the primary key. That is a bit of a problem. This is what I mean by the traditional relational database model. This is the purest way of doing it. This is how many years ago the relational database model was invented, where you pass the primary key into the composite of the child table and so on down the hierarchy.